Hello everyone, this is Miss Rutuja Kade, BTech final year student in Civil Engineering from Anna Sahib Dange College of Engineering and Technology, Ashta. Today I am here to present one topic with you, that is the relay waves from subject Earthquake Engineering. So we'll start with the introduction, that what actually the seismic waves. So seismic waves are the vibration generated by an earthquake, explosion or similar energetic source and propagates within the earth or along its surface. So these are just waves, or we can say it as a seismic waves or vibration that shake up the earth surface as a whole. Next, earthquake generate four principal types of the elastic waves. That is, two are body waves and two are the surface waves. They are again classified into two categories. We will discuss about this further. So the seismographs are used to record the amplitude and the frequency of this seismic waves. Okay, next is the artificial generated seismic waves recorded during the seismic surveys are used to collect the data in oil and gas prospecting and engineering also. So as I told about the seismic waves categories, that is the classification of the seismic waves. They are broadly classified into two, as you can see here, that is the body waves and the surface waves. So the body waves, as the name indicates, these waves are generated in the earth's surface, that is inner side of the earth crust, and second is the surface wave. Their effect and these waves are also confined near the surface of the earth. Okay, so body waves are again classified into two categories, that is the longitudinal waves, which is also known as P waves, and primary waves also. Second is the transverse waves, is known as the secondary waves or shear waves. So the longitudinal waves, in these waves propagates in the direction which is parallel to the earth's surface. Okay, and in transverse it is opposite, that is wave propagates in the direction which is perpendicular to the earth's surface. Okay, next is the surface waves. Surface waves are broadly classified into two, that is Rayleigh waves and the Love waves. Rayleigh waves are similar to that of the longitudinal wave, but only difference is that these are the surface waves and their effects, or we can say its amplitude, is going to decrease as we go in depth from the earth's surface. And the Love waves are similar to transverse, and the same difference is that their amplitude decreases as the depth of the earth's surface going to increase. Okay, next is the relay wave, which is our main topic of discussion. So relay waves, this is a type of seismic surface wave that moves with a rolling motion that consists of a combination of particle motion perpendicular and parallel to the main direction of the wave propagation. The amplitude of this motion decreases with depth, as I told earlier, and like primary waves, the relay waves are alternately compressional and extensional. Okay, relay waves travel slower than the Love waves, that is Love waves, which is similar to the S waves or shear waves. The speed of the relay waves is slower than that Love waves. Okay, next is the relay waves. I told about the alternate compression and extension is observed in the relay waves. So the figure is shown here about this relay waves. Okay, next is we see some of the characteristics of the relay waves. So relay waves is a secondary wave characterized by a low frequency and strong energy, propagating mainly along the interface of medium and rapid attenuation of energy with increase in interface difference. Okay, the main same as reflected waves and the refracted waves. Relay waves also contain subsurface geological information. Okay, propagates typically at slightly more than 90% of the shear wave speed. As I told, shear waves similar to the Love waves, speed is slower than the Love waves, that means speed is slower than the shear waves. Okay, it involves an elliptical path of particle motion that lies in a plane parallel to that defined by a normal to the surface and the propagation direction. As I told about this, the direction of the propagation is parallel to the earth's surface. That's so we'll see some of the characteristics of the relay waves. So the relay waves have a speed slightly less than the shear waves by a factor dependent on the elastic constants of the material. The typical speed of the relay waves in the material is of the order of 2 to 5 kilometers per second, and the typical relay speed in the ground is of order of 50 to 300 meter per second for shallow waves, and less than 100 meter depth, and 1.5 to 4 kilometer per second at depths greater than 1 kilometer. Okay, Since Rayleigh waves are confined near the surface, they're in a plane amplitude. When generated by a point source, decays only as 1 divided by under root r, where r is the radial distance here. Okay, so that is in general discussion about the Rayleigh waves. So that's all about from my side. Thank you so much.